Hello, Bolivians! It's me again, Ma'am MJ, and welcome to Math Class. Our topic for today is about arithmetic series. So, according to Merriam-Webster, series is a number of things or events that are arranged or happen one after the other. In mathematical term, it is the sum of the terms of a sequence, and it is a group of numbers separated by a plus sign. So when we say arithmetic series, it is the sum of the terms of a arithmetic sequence. In arithmetic series, we have the nth partial sum of a series. So it is the sum of the first n terms of the sequence. We express it as S sub n is equal to A sub 1 plus A sub 2 plus so on plus A sub n. So I have here a table showing the difference between arithmetic sequence and arithmetic series. For arithmetic sequence, we have 2, 4, 6, 8, 10, while in arithmetic series, we have 2 plus 4 plus 6 plus 8 plus 10. So the series associated with the arithmetic sequence 2, 4, 6, 8, 10 is S sub n is equal to 2 plus 4 plus 6 plus 8 plus 10, where n is equal to 5 because there are 5 terms in the sequence. So let's try this example. Consider the sequence 3, 5, 7, 9, 11, 13, and 15. Find the sum of the corresponding series S sub 7. Notice that the given sequence is an arithmetic sequence. Therefore, S sub 7 is an arithmetic series. We can apply the different properties of addition to find the sum of the series. Consider the sequence 3, 5, 7, 9, 11, 13. Using the nth partial sum of a series, n is equal to 7. So we have a sub 1 is equal to 3, a sub 2 is equal to 5, a sub 3 is equal to 7, a sub 4 is equal to 9, a sub 5 is equal to 11, a sub 6 is equal to 13, and a sub 7 is equal to 15. Using associative property of addition, we have S sub 7 is equal to the quantity of 3 plus 5 plus the quantity of 7 plus 9 plus the quantity of 11 plus 13 plus 15. Then simply add. So we have 3 plus 5 is 8, 7 plus 9 is 16, 11 plus 13 is 24, then plus 15. Then again, using associative property of addition, we have 24 or the quantity of 24 plus 24 plus 15. So we have 48 plus 15 and 48 plus 15 is equal to 63. So therefore, the sum of the 7 terms of the arithmetic series is 63. To find the sum of a given series, you may add the terms of the sequence one by one. However, when the number of terms of a sequence is large, it will be a tedious task to add the terms one at a time. There are other ways in calculating the sum of the first n terms of the sequence. So first, we have S sub n is equal to n times the quantity of a sub 1 plus a sub 2 all over 2, where a sub 1 is the first term and a sub n is the nth term of the sequence. So, alternatively, because a sub n is equal to a sub n plus the quantity n minus 1 times d, or the common difference, the equation may also be written as follows. So, we have, for letter B, S sub n is equal to n times the quantity of 2a sub 1 plus the quantity of n minus 1 times d over 2. Here's some example. Letter A, given the arithmetic sequence with a sub 2 is equal to 8 and a sub 4 is equal to negative 2. Find the sum of the first 5 terms of the sequence. For the solution, the unknown parts are a sub 1 and d, which is the common difference. So, let a sub 2 is equal to a sub 1 and a sub 4 is equal to a sub 3.
For the solution, using a sub n is equal to a sub 1 plus n minus 1 times d, let's substitute the given values. Now, n is equal to 3. So, a sub 3 is equal to a sub 1 plus 3 minus 1 is equal to d. So, we have negative 2 is equal to 8 plus 2d. Add negative 8 to both sides of the equation. So, we have negative 10 is equal to 2d. Now, divide both sides of the equation by 2. So, our common difference is negative 5, or d is equal to negative 5. To find a sub 1, substitute the value of d, then multiply. Add negative 15 to both sides of the equation. Therefore, our a sub 1 is equal to negative 13. To get a sub 5, add the common difference to a sub 4. So, a sub 5 is equal to negative 2 plus negative 5 is equal to negative 7. To solve for the required sum using S sub n is equal to n times the quantity of 2a sub 1 plus n minus 1 times d over 2, let's substitute. So, S sub 5 is equal to 5 times the quantity of 2 times 13 plus 5 minus 5 times negative 5 over 2. We get 5 times the quantity of 2 times 13 plus 4 times negative 5 over 2. Let's simplify. So, 5 times the quantity of 26 plus negative 20 over 2. So, S sub 5 is equal to 15. Here's another example. Letter B. Find the sum of the arithmetic series S sub n is equal to 1 plus 5 plus 9 plus 13 plus so on plus 45 plus 49. First, identify the value of n. So, for the given, we have a sub 1 is equal to 1, a sub n is equal to 49, the common difference is equal to 4, and our n is the unknown part. For the solution, using this formula, a sub n is equal to a sub 1 plus n minus 1 times d. Substitute the given value. So we have 49 is equal to 1 plus n minus 1 times 4. Then simplify. 48 is equal to 4n minus 4. So n is equal to 13. Now that we have the value for n, let's solve for the sum of the arithmetic series. So, S sub 13 is equal to 13 times 1 plus 49 over 2. So, we have 13 times 25 is equal to 325.
So that's our topic all about. I hope that you learned a lot today, and I'm praying that you're all in a good health. Thank you and see you next video.